Welcome to this Basis Classroom module, Maximising Weed Control with Adjuvant Technology. I'm Stuart Sutherland, Technical Manager at Interagro. During this short course, we will explain the reasons why getting the most out of herbicides is more important than ever. Have you ever applied a pre-emergence herbicide and wondered why the control levels are lower than you expected? Have you experienced weed problems during difficult weather seasons, too dry or too wet perhaps? Have you suffered from crop damage where herbicides have been washed down during heavy rain to more sensitive parts of the plant? Some of these questions help us understand the why. Why do we not always achieve the best levels of control? Herbicide programs are an investment, and you want to get the best weed control you can. Getting as close as possible to the theoretical maximum weed control from the chosen mixture is always the objective, but it doesn't always work out that way when other factors are brought into the equation. So, over the course of this Basis classroom, we look at some of the reasons why herbicides might not work to their full potential and consider the use of adjuvants to help overcome some of the obstacles to full control. This short course is broken down into a few sections, starting with a look at delivery of herbicides from the sprayer, coverage and distribution, and fate in the soil. Next, we will look at the investment by the grower and the impact poor weed control can have on yield and other important aspects. Following on, we consider herbicide properties in the soil and how different active ingredients behave under different circumstances. And finally, we cover the benefits of adding an adjuvant to residual herbicides and how it can help alleviate some of the problems we face. To start off, we need to understand the journey our herbicide has taken to reach its destination. Delivery of the active ingredients from the sprayer to the soil is challenging, and it has many forces working against it. Weeds generally germinate in the top 5 centimetres of the soil, so our residual active ingredients need to have good coverage on the soil and stay in that germination zone for as long as possible. During this course, we will be focusing on the delivery, placement and efficacy of residual herbicides. It is important to understand that the target for these herbicides is the soil. Residual herbicides control weeds through contact with roots and shoots of newly germinating and emerging weeds. Disrupting biochemical pathways, these actives leading to irreversible damage, tissue injury and eventual death. It is our duty under the Sustainable Use Directive to consider all integrated crop management options before using a herbicide. Much press goes to blackgrass control here in the UK. However, the importance of considering rotation, seed rates, sowing dates, stale seed beds, cultivation types, etc. is equally important for managing all weed populations in winter and spring cropping. Other considerations around stewardship can be found on the Voluntary Initiative website and include tools such as When to Go, which gives advice on applications of metazoclor and quinmerac according to local weather and soil conditions. Thinking back to herbicide delivery, there are a few things we need to consider about the journey. The short distance from the nozzle to the soil may only be around 50 centimetres, but already there are lots of factors working against us for ideal application. It's not that easy to maintain 50 centimetre boom height when driving over a bumpy field with a large sprayer. On top of that, trying to maintain a reasonable speed to keep up the workflow, but slow enough to ensure good application. To help keep drift in check, forward speed should ideally be between 10 and 12 kilometres an hour. The potential loss of herbicide to the environment through drift is not only going to reduce active ingredient going to where it needs to be, but also potentially dangerous to adjacent fields, hedges and other off-target species. Reduction of drift through careful management of forward speed, nozzle choice and boom height can ultimately improve overall weed control. The use of a low drift nozzle can help reduce drift, but can often have a negative effect on coverage and distribution. The use of an approved adjuvant, which has drift reducing properties, should also be considered. Once our droplets have landed on the soil, the spread and concentration of active ingredient will have an impact on the level of weed control. When we talk about coverage, we're making reference to how much product is over a given area. Distribution is how evenly the product is spread over the same area. To give an example, you could spread a set amount of pepperoni to cover half a pizza, but it probably wouldn't look as intended. If that same quantity of pepperoni was spread evenly across the whole pizza, the coverage would be the same, but the distribution would be far better. There are many things that will affect how even distribution is. Firstly, the soil tilth. If the seed bed is not ideal, then it's very difficult to achieve coverage on and under larger clods. A more cloddy seed bed is a more difficult surface area to try and treat. A further consideration is the later breakdown or weathering of these clods and their ability to release a second flush of weeds. Secondly, nozzle choice, water volume and pressure can also affect the distribution. As can be seen here, these examples offer very different patterns on the water-sensitive paper. These tests were carried out on a flat surface, so add in the uneven soil texture, some clods, and it becomes easy to see why pre-emergence weed control can be challenging. While we wait for weeds to germinate and herbicide to take effect, we find ourselves faced with other factors detrimental to full control. Prolonged periods of germination require herbicides to stay where they were placed for as long as possible. This ensures the active ingredient is not diluted through leaching from rainfall, breakdown from photodegradation, or reduced availability from the soil drying out. This is the most difficult part of the herbicide delivery to manage because we have no control over the weather. The loss of herbicide through leaching has to be avoided. The negative effect on our industry from finding traces of crop protection products in water and the huge expense of removing them is always top of mind. Maximising weed control and reducing loss to groundwater go hand in hand, and they are both hugely beneficial and can be improved through careful management. In 2017, a trial was set up in the Netherlands on a commercial field of seed onions. The soil was very light and the normal applications of herbicide were applied. There was a pre-emergence application of pendimethalin, then follow-up post-emergence treatments containing the actives seen here. This setup used buried plastic pots to be able to catch the leachate after a significant rainfall event to see how much crop protection product was leaving the top 5 centimetres of the soil. After a significant rainfall event of 56 millimetres in July, the leachate was analysed and it was found that the post-emergence treatments of chloridazone, dimethenamide and fluroxypyr were showing signs of leaching. We have looked at the journey from sprayer to soil and the factors working against us achieving full weed control. On top of the physical aspects of this journey, we are also facing increased pressures from resistance, loss of actives, herbicide rate reductions through regulatory pressure, challenging weather patterns, and difficult seed beds. Controlling grass weeds, especially blackgrass and winter wheat, is very expensive. The investment required to control blackgrass can be in excess of £150 a hectare. Only 12 plants per square metre are required to reduce wheat yields by 5%, and more severe infestations of 100 plants per metre squared can reduce yields by 20%. The magic number of 98% control has to be achieved to ensure we're not increasing the seed population in the soil. Other grass weeds, such as annual meadowgrass, bromes and ryegrass, can also be challenging if we encounter difficult conditions at or after application. Italian ryegrass, for example, is even more competitive than blackgrass, with 5% yield loss in wheat being typically seen from just 5 plants per square metre. When we look at broadleaved crops, such as potatoes or pulses, we're also looking to maximise both grassweed and broadleaved weed control with the pre- or peri-emergence treatment. The loss of dicot certainly makes life more difficult for the early weed control in potatoes. Relying more on getting the most out of residual options is more important now than ever. Getting the best control early saves time and money later with follow-up applications. A pre- and peri-emergence application of herbicide is usually designed to control grass weeds and broadleaved weeds. Maximising control of all target weed species in spring and autumn crops is key to avoiding costly secondary applications at a later date, and to help minimise the build-up of resistant populations, as we've seen over the years on mayweed, chickweed and poppy. On top of that, the potential for certain weeds to harbour disease or act as a green bridge for pests just bolsters the message of maximising weed control. Consideration as to the coming weeks after an application can help when thinking about the approach. For autumn applications, it's likely to start getting wetter in the run-up to winter, Germination may be prolonged due to cool conditions and darker days, yet we need a herbicide to remain in the top 5 centimetres of the soil and to work as long as possible. In the spring, the opposite could be true, with the likelihood of soil drying up after sowing. Warmer days and more day length could encourage a shorter germination period. There may be some moisture at depth to allow the weeds to grow, but the top few centimetres may be dry and herbicides may struggle to be as effective. Herbicides have unique characteristics influencing their behaviour in the soil. Their water solubility, adsorption ability, and half-life all affect the end result of trying to maximise weed control. The more water-soluble a herbicide, the more likely it is to leach during a heavy rainfall event. One of the benefits of a water-soluble herbicide is its ability to move a bit in the top layer of the soil, so it can be beneficial to weed control. When we talk about adsorption, we're making reference to the ability of the herbicide to bind to soil colloids. Soil colloids are made up of the smallest particles of organic matter and clay. In the event of dry weather, herbicides with high adsorption characteristics bind more tightly to colloids and become less available. Solubility and adsorption determine how much of the herbicide will be bound versus in solution. Residual herbicides must be absorbed into the roots or shoots of a weed to be effective. Herbicides dissolved in soil water move into weeds as their roots absorb water from the soil. To do so, herbicides need to be in soil solution and be in a position in the soil to be absorbed by the roots and emerging shoots. We now know that herbicide absorption influences availability and efficacy. Absorption of the herbicide to soil colloids, such as clay or organic matter, occurs due to the attraction between charges on soil colloid surfaces and herbicide molecules. To be effective and safe, the majority of the herbicide must be bound to the soil colloid with only a small amount remaining in solution. Herbicides bound to soil colloids are less available to weeds than those in solution. The level of herbicide in solution is directly related to soil moisture content. When there is adequate moisture, more of the herbicide remains in the soil water. However, when soils start to dry out, less water is present, so more of the herbicide is bound to the soil colloids and therefore less available. Poor weed control typically occurs in dry soils as less herbicide is in the soil water. Herbicides need to be retained in the root zone of the germinating weeds. Unless incorporating, some rainfall is required to move herbicide from soil surface to the weed root and shoot zone. The amount varies depending on soil moisture ahead of application and soil type. Too much rain can push damaging herbicides into crop root zone, increasing the risk of phytotoxicity, or just leach them away altogether. With excessive rainfall, herbicides that are even moderately mobile can be lost. Efficacy can be improved by increasing herbicide retention or soil moisture. When we break down adsorption and water solubility, we can see from this table that products containing actives that have high adsorption characteristics, for example pendimethalin or picolinophen, need more moisture to remain available to the weeds. Their efficacy will suffer most during a dry period because they bind more tightly to soil colloids as soil moisture dries up. Looking at products with high soil mobility, such as amazamox or metribuzin, they are more susceptible to leaching during wet periods. When choosing a herbicide program, the result is usually based on more than one active ingredient. If there is an overlap on weed spectrum between actives, this can not only help with the considerations of reducing resistance buildup, but usually improves overall weed control. When taking soil moisture into account, we can start to see some synergy. For example, as soils dry out in spring, less mobile herbicides will become less available, whilst the more mobile herbicides shouldn't be affected as much. The less mobile actives usually last longer in the soil, so a later rainfall event can help reactivate and work towards later germinating weeds. For more than 10 years, growers have been using residual herbicide adjuvant Backrow to help maximise their weed control. Backrow is easy to mix and added to the spray tank with the pre or peri emergence herbicides. In the UK, adjuvants have to be approved by our regulation authorities, CRD. This means there are specific crop approvals and growth stage cut-offs. Because Backrow is used right at the start of the growing period, we are not affected by the growth stage cut-offs. Like with crop protection products, CRD also have a specific adjuvant database on their website where you can check which crops are approved and any restrictions which might apply. Earlier, we discussed the potential effect of losing herbicide to drift and the difficulties of getting good coverage on the soil. One of the key benefits of Backrow is that it has a beneficial effect on the spray droplets. As can be seen here, this study at Celso showed an increase in VMD, volume median diameter, effectively the average size of the droplet, and a decrease in the number of droplets which are smaller than 100 microns. 100 microns is a tenth of a millimetre. These are deemed to be the most drift-prone droplets, so with the inclusion of Backrow, more of the herbicide will land at its intended destination, therefore aiding improved weed control. The benefit of reducing drift and influencing droplet size has a positive effect on coverage. When we look at these water-sensitive paper experiments, we can see the improvement of coverage where Backrow was added to this Crystal Plus Liberator mix when tested with two different nozzle types. The paper on the left of each photo had the inclusion of Backrow. The combination of less drift and more coverage means we have more herbicide where it needs to be to get our weed control off to the best possible start. Backrow contains a specially developed blend of oils, surfactants and emulsifiers. Designed to improve retention of herbicide in the top 5 centimetres of the soil, Backrow has been proven to benefit both very mobile herbicides and also those with low mobility or high adsorption. It works by binding onto the herbicide and the water as well as the soil colloids. This binding slows the leaching of herbicide during rainfall events to keep the concentration where it needs to be for maximising weed control. Earlier, we looked at work showing the leaching of herbicides in an onion field. Following on from that, there was also a treatment included in this trial where Backrow was applied with the pre-emergence treatment. These are represented by the blue bars. You can see that even though the Backrow was applied at an earlier date, it was still having an effect on post-emergence herbicide in reducing their ability to leach into groundwater. A further replicated study was set up using lysimeters to catch any leachate after an irrigation event on these chrysanthemums. Where Backrow was added in the mix, a 62% reduction in leaching of crop protection product and a 33% reduction of water leaching was observed. For herbicides that are less mobile and adsorb tightly in dry conditions, Backrow can help retain some moisture in the top layer of the soil, which ensures less mobile herbicides can still provide some efficacy. Backrow is used successfully around the world in helping growers get the most out of their herbicide programs. Over the last 10 years, trials have shown average improvements in grass weed control of 9% and broadleaf weed control of up to 14%. Backrow should be used at 0.4 litres a hectare in the spring or at 0.2 litres a hectare in the autumn. To summarise, Backrow improves coverage and distribution by reducing drift. It increases herbicide uptake into the weeds by retaining moisture and increasing herbicide retention in the top 5 centimetres of the soil, giving more effective weed control in dry conditions, and improves safety to crops, groundwater and off-target species. Thank you for completing this BASIS classroom course. For more information on Backrow or any of our solutions, please visit www.interagro.co.uk where you can find lots more information. Alternatively, feel free to get in touch with myself on 07 384 460 352 or email stuart.sutherland@interagro.co.uk. Thank you.